A botnet is a collection of Internet-connected programs communicating with other similar programs in order to perform tasks. This can be as mundane as keeping control of an Internet relay chat channel, or it could be used to send spam email or participate in distributed denial-of-service attacks. The word botnet is a combination of the words robot and network. The term is usually used with a negative or malicious connotation. Legal botnets. The term botnet is widely used when several IRC bots have been linked and may possibly set channel modes on other bots and users while keeping IRC channels free from unwanted users. This is where the term is originally from, since the first illegal botnets were similar to legal botnets. A common bot used to set up botnets on IRC is eavesdrop. Illegal botnets. Botnets sometimes compromise computers whose security defenses have been breached and control conceded to a third party. Each such compromised device, known as a bot, is created when a computer is penetrated by software from a malware distribution. The controller of a botnet is able to direct the activities of these compromised computers through communication channels formed by standards-based network protocols such as IRC and Hypertext Transfer Protocol. Recruitment. Computers can be co-opted into a botnet when they execute malicious software. This can be accomplished by luring users into making a drive-by download, exploiting web browser vulnerabilities, or by tricking the user into running a Trojan horse program, which may come from an email attachment. This malware will typically install modules that allow the computer to be commanded and controlled by the botnet's operator. Depending on how it is written, a Trojan may then delete itself, or may remain present to update and maintain the modules. The first botnet was first acknowledged and exposed by Earthlink during a lawsuit with notorious spammer Khan C. Smith in 2001 for the purpose of bulk spam accounting for nearly 25% of all spam at the time. Organization. While botnets are often named after the malware that created them, multiple botnets typically use the same malware, but are operated by different entities. A botnet's originator can control a group remotely, usually through IRC, and often for criminal purposes. This server is known as the command and control server. Though rare, more experienced botnet operators program command protocols from scratch. These protocols include a server program, a client program for operation, and the program that embeds the client on the victim's machine. These communicate over a network, using a unique encryption scheme for stealth and protection against detection or intrusion into the botnet. A bot typically runs hidden and uses a cover channel standard, Twitter, or IM, to communicate with its CNC server. Generally, the perpetrator has compromised multiple systems using various tools. Newer bots can automatically scan their environment and propagate themselves using vulnerabilities and weak passwords. Generally, the more vulnerabilities a bot can scan and propagate through, the more valuable it becomes to a botnet controller community. The process of stealing computing resources as a result of a system being joined to a botnet is sometimes referred to as scrumping. Botnet servers are typically redundant, linked for greater redundancy so as to reduce the threat of a takedown. Actual botnet communities usually consist of one or several controllers that rarely have highly developed command hierarchies. They rely on individual peer-to-peer relationships. Botnet architecture evolved over time, and not all botnets exhibit the same topology for command and control. Advanced topology is more resilient to shutdown, enumeration or discovery. However, some topologies limit the marketability of the botnet to third parties. Typical botnet topologies are star, multi-server, hierarchical and random. To thwart detection, some botnets are scaling back in size. As of 2006, the average size of a network was estimated at 20,000 computers. Formation. This example illustrates how a botnet is created and used to send email spam. A botnet operator sends out viruses or worms, infecting ordinary users' computers, whose payload is a malicious application the bot. The bot on the infected PC logs into a particular CNC server. A spammer purchases the services of the botnet from the operator. The spammer provides the spam messages to the operator, who instructs the compromised machines via the control panel on the web server, causing them to send out spam messages. Botnets are exploited for various purposes, including denial of service attacks, creation or misuse of SMTP mail relays for spam, click fraud, mining bitcoins, spamdexing, and the theft of application serial numbers, login IDs, and financial information such as credit card numbers. The botnet controller community features a constant and continuous struggle over who has the most bots, the highest overall bandwidth, and the most high-quality infected machines, like university, corporate, and even government machines. Types of attacks. In distributed denial of service attacks, multiple systems submit as many requests as possible to a single Internet computer or service, overloading it and preventing it from servicing legitimate requests. An example is an attack on a victim's phone number. The victim is bombarded with phone calls by the bots, attempting to connect to the Internet. Adware advertises a commercial offering actively and without the user's permission or awareness, for example by replacing banner ads on web pages with those of another advertiser. Spyware is software which sends information to its creators about a user's activities, typically passwords, credit card numbers and other information that can be sold on the black market. Compromised machines that are located within a corporate network can be worth more to the bot herder, as they can often gain access to confidential corporate information. Several targeted attacks on large corporations aim to steal sensitive information, such as the Aurora botnet. Email spam are email messages disguised as messages from people, but are either advertising, annoying, or malicious. Click fraud occurs when the user's computer visits websites without the user's awareness to create false web traffic for personal or commercial gain. Fast flux is a DNS technique used by botnets to hide phishing and malware delivery sites behind an ever-changing network of compromised hosts acting as proxies. Brute forcing remote machine services such as FTP, SMTP and SSH. Worms. The botnet focuses on recruiting other hosts. Scareware is software that is marketed by creating fear in users. Once installed, it can install malware and recruit the host into a botnet. For example, users can be induced to buy a rogue antivirus to regain access to their computer. Exploiting systems by observing users playing online games such as poker and see the player's cards. Countermeasures. The geographic dispersal of botnets means that each recruit must be individually ID'd, feed repaired and limits the benefits of filtering. Some botnets use free DNS hosting services such as dyndns.org, no-ip.com, and afraid.org to point a subdomain towards an IRC server that harbors the bots. While these free DNS services do not themselves host attacks, they provide reference points. Removing such services can cripple an entire botnet. Some botnets implement custom versions of well-known protocols. The implementation differences can be used for detection of botnets. For example, MegaD features a slightly modified SMTP protocol implementation for testing spam capability. Bringing down the MegaD's SMTP server disables the entire pool of bots that rely upon the same SMTP server. The botnet server structure mentioned above has inherent vulnerabilities and problems. For example, finding one server with one botnet channel can often reveal the other servers, as well as their bots. A botnet server structure that lacks redundancy is vulnerable to at least the temporary disconnection of that server. However, recent IRC server software includes features to mask other connected servers and bots, eliminating that approach. Security companies such as Affront Security Labs, Symantec, Trend Micro, FireEye, Umbra Data and Damballa have announced offerings to counter botnets. Norton Antibot was aimed at consumers, but most target enterprises and/or ISPs. Host-based techniques use heuristics to identify bot behavior that has bypassed conventional antivirus software. Network-based approaches tend to use the techniques described above. Shutting down CNC servers, null routing DNS entries, or completely shutting down IRC servers. Bot Hunter is software, developed with support from the U.S. Army Research Office, that detects botnet activity within a network by analyzing network traffic and comparing it to patterns characteristic of malicious processes. Some newer botnets are almost entirely P2P. Command and control is embedded into the botnet rather than relying on external servers, thus avoiding any single point of failure and evading many countermeasures. Commanders can be identified just through secure keys, and all data except the binary itself can be encrypted. For example, a spyware program may encrypt all suspected passwords with a public key that is hard-coded into it, or distributed with the bot software. Only with the private key can the data captured by the bot be read. Some botnets are capable of detecting and reacting to attempts to investigate them, reacting perhaps with a DDoS attack on the IP address of the investigator. Researchers at Sandia National Laboratories are analyzing botnets' behavior by simultaneously running 1 million Linux kernels a similar scale to a botnet as virtual machines on a 4,480-node high-performance computer cluster to emulate a very large network, allowing them to watch how botnets work and experiment with ways to stop them. Historical list of botnets. Researchers at the University of California, Santa Barbara took control of a botnet that was 6 times smaller than expected. In some countries, it is common that users change their IP address a few times in one day. Estimating the size of the botnet by the number of IP addresses is often used by researchers, possibly leading to inaccurate assessments. See also, anti-spam techniques, computer worm, DoSNet, email address harvesting, email spam, list poisoning, spambot, spam trap, timeline of notable computer viruses and worms, zombie computer, references. External links, Wired.com. How to build your own botnet with open source software, the HoneyNet Project and Research Alliance, Know Your Enemy, Tracking Botnets. The Shadow Server Foundation, an all-volunteer security watchdog group that gathers, tracks, and reports on malware, botnet activity, and electronic fraud. NANOG Abstract, Botnets, John Christoph's NANOG 32 Botnets presentation. Mobile Botnets, an economic and technological assessment of mobile botnets. Locasoft, intrusive analysis of a web-based proxy botnet. bweek.com, is the botnet battle already lost? Attack of the bots at Wired, Dark Reading, Botnets battle over turf. Atlas Global Botnet Summary Report, real-time database of malicious botnet command and control servers. FBI lacks press release. DOJ, FBI April 16, 2008, Milcord Botnet Defense, DHS-sponsored N-D project that uses machine learning to adaptively detect botnet behavior at the network level. A Botnet by Any Other Name, Security Focus column by Gunter Ullman on botnet naming. Botnet bust, spy malware mastermind pleads guilty, FBI.